The 8th question says, find the value of x for which the points this and this are collinear. Now for collinearity, what are the concepts that you have? Let's take a look at the concepts. For collinearity, you have studied some things before and you can use concepts related to that. If there are 3 points, let us say A, B and C, you can use distance formula, that is AB plus BC if equal to AC, then you can say that the points are collinear. You may use section formula as well. What does the section formula say? That if you can find some lambda for which the x coordinate of B can be found with the help of this lambda is to 1 ratio of AC, and similarly the value of lambda for y coordinate will be found if lambda for x and lambda for y are equal. Therefore this particular point will lie on that particular line segment. Yes, and therefore you can say that the points are collinear. This is using section formula. Okay, what else? Third approach could be directly using the concepts of slope. So m of AB and m of AC. Can you observe that the slope of AB and slope of AC, if they are same, then you can say that the points are collinear. Another approach could be using concepts of area of triangle. Area of triangle ABC, if it is 0, then you can say that yes, the 3 points A, B and C are collinear. That's another approach that you can follow with regards to this, right? And for area, you have x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y3 minus y1, the formula which you have seen some questions back, right? In the first question of this exercise, we have revised that formula, right? So any of these approaches can be used, but here we'll be using which of these approaches. So distance formula you have already solved, section formula you have already solved, the previous classes, area you have already solved. Here we'll be discussing using this concept of slope. Since slope is something new which you have learned for this exercise, let's deal with this question using concepts of slope. Let A x comma minus 1, B 2 comma 1 and C 4 comma 5 be the given points. This is be the given points, okay? And it is given that these points are collinear. Since it is given that these points are collinear, therefore m of AB will be equal to m of AC, or you can say m of BC. Is that okay? Yes. Will that make any difference? No, it will not make any difference, right? So m of AB, m of BC and m of AC all are equal, right? So this is okay, or you can write it as this as well. Now why am I using BC over here? Why not writing it as AC? You see, the vertex A has the variable x. Why write x twice? Why not write it only once, right? So we have done that. For slope of AB, you have y2 minus y1, which is 1 plus 1 upon x2 minus x1, which is 2 minus x. Don't make a mistake in writing this expression, right? This minus this, therefore this minus this will come in the denominator. For BC, you have 5 minus 1 in the numerator, so 4 minus 2 will come in the denominator. This is what you'll have. What is that? This is 2 upon 2 minus x, which is equal to 4 upon 2. This goes twice. Okay, so this becomes 2 simply, and what you have, 2 is equal to 2 times 2 minus x. This 2 goes, this becomes 1. 1 is equal to 2 minus x, or x is equal to 2 minus 1, which is 1. That is the required answer for this question. Concepts of collinearity have been discussed, and we have used idea of slope to find this x. You can also observe that any of these approaches, other approaches, will require more calculations than this approach. This is the latest one that we have studied, right? You can solve the question using 1, 2 and 4th approach as well. But this is the least calculation approach, and that's the complete solution for this question over here.